Understand, so previous videos we have seen what is the mechanical ventilator, okay, and what are different types of ventilation methods, what are the parameters we have seen. Now you need to design or develop a modern ventilator. Okay, so what are the ventilator that is available in the hospitals? So what are the various different complicated circuit units, and what are different ventilators that they use, we will be seeing in this video. So in this video I will be showing you, or I will be guiding you through what are the various different topics that you need to write while you are discussing modern ventilators. Okay, so these modern ventilators, if you see, it is a combination of a manual thing, automated. Okay, so the manual thing, as we saw, the balloons that has to be pressed manually, or now we are controlled using pneumatic controllers or electronic controllers to pace the breathing cycle in as required, or as based on the patient's required set by the doctor. Okay, and the different flow rates can be controlled, volumes can be controlled, pressure can be controlled, so that the parameters of the patient, such as the tidal volume, inspiratory phase, expiratory phase, mean pressure, arterial pressure, respiration rates, lung compliance, can be precisely controlled. Okay, and at last they're all controlled by a central system called microprocessor, or a control system that sequentially or parallelly controls every aspect based on the program written into it. Okay, it also measures the temperature of the air, because another important thing is inspirated air temperature and expiratory air temperature are different. Okay, because when you can even feel that when you expire the air, air is bit heated up when compared to the inspirated air. Okay, so temperature also plays a vital role. Measurements, what I mean by temperature is temperature measurement plays a vital role in design and development of microprocessor based control ventilators. Okay, and as we saw in positive pressure ventilator, when we discussed in the previous videos, there are like different modes: spontaneous breathing mode, another one is mandatory breathing mode. So these modes can also be set if it is written programmatically. You can set these modes based on the need of the patient, as well as by the medication given by the, or therapy given by the doctor. Okay, and if you go into the deeper, what are the electronics of microcontroller, the compressor, the nebulizers, what are the important components involved in the, can also be because these components are various different submodules that has to be relating with each and every you need to make them work. For example, pressure sensor, volume sensor, flow sensor, power management system, all are to be worked simultaneously and controlled and monitored by the microcontroller and other system to make a precise working of the ventilator. There are also high frequency ventilators. Okay, what are these high frequency ventilators? A new technique for ventilating patients at frequencies much higher than the respiratory rate has recently been seen. This method has been shown to improve the CO2 washout and provide adequate oxygenation without requirement of high inspiration pressure. The key principle in this technique is to provide tidal volumes equal to or greater than the dead space at very high. So there are also something called dead space. So what is this dead space? So when you make an inspiration and you complete the inspiration and expiration, there is always a small amount of air, that is residual volume, and the space that it occupies is the dead space. Okay, when you try to forcibly expire, expiration is a passive cycle. When you try to forcibly expire, what happens is that you still expire some more amount of, so that space, that volume is residual volume, and that space occupied is the dead space. Okay, and for example, in certain conditions, in certain requirements, you need a more number of cycles than the normal breathing cycle, or normal inspiratory cycle or expiratory cycle. So you use an high frequency, so high frequency more speed system. So when you use this, what they say is that CO2 is getting more washed out more quickly, and this oxygen is getting more quickly into the blood, and this improves the recovery period. Okay, and their details are as given below. Okay, so when you write these things, high frequency ventilators, and these are the modern ventilators and stuff, you should write about this microcontroller based ventilator, and what are the assiding related allied ventilator electronic systems, because the microprocessor itself is an electronic system, right? So you should understand and write everything from that. And finally, the nebulizer. Apart from ventilation, humidification of the breathing plays a leading role in intensive care patients. The main task of the humidifier is to replace the humidity in the upper air passages, which has been lost by incubation. The humidity should be as close as 100% as possible. Speaking in terms of water, the absolute content per breathing gas should not be more than 30 mg. regardless of the environment. Therefore, in order to prevent damage to the patient lungs, the air oxygen applied during the respiratory therapy must be humidified. Okay, thus all ventilators include arrangement of humidify the air either by heat vaporization stream or by bubbling an air through the jar of water. When water or some type of medication is suspended in inspired air, an aerosol is to be administered to the patient. The device is called nebulizer. When you want to medicate the person who is actually going through this ventilation process, what you do is you provide a aerosol or finely grinded or powdered or small droplets of medicine into the system in this with a device called nebulizer. So the water or the medication is picked up by the high velocity of the jet of oxygen and air and made impact against one of the more baffled break the substance into controlled size droplets, which are then applied to the patient via respirator. More effective and efficient nebulizers are based on the use of high intensity ultrasound energy, which vibrates the substance to produce a high volume of minute particles. Ultrasonic nebulizers do not depend upon breathing gas for operation, and thus therapeutic agents can be conveniently administered during ventilation procedure. Aspirators are often included as a part of ventilator to remove the mucus and other fluids from the airways. Alternatively, the separate suction device may be utilized to achieve the same purpose. So, humidifier is to humidify the air so that it doesn't damage the interportions of the lungs. Nebulizers are used to when medication is suspended in inspired air, an aerosol is to be administered to the patient. A device, so it should be in the form of a aerosol, not a direct medication. So that purpose is provided by a nebulizer. Okay, and these nebulizer are based on high intensity ultrasound energy, which can basically provide and reach better effect to the patient. Okay, so these are the nebulizer and humidifiers that have been used in the modern ventilators. So when you are asked about to write a modern ventilator, you should start from the entire block diagram and the block diagram of its aligning electronic circuits, followed by the high frequency ventilators, then the humidifiers and nebulizers. Okay, thank you.